morning, everyone. It's a pleasure to be here. It's my first time in Finland. I have always wanted to come here. I've heard about how lovely and sunny and balmy warm it can be this time of year. I sent my wife a couple of emails and texts, and I said, I woke up to minus 22 this morning. I hope things are a little warmer in Redmond. So I have to say, I've been a long fan of Nokia, and I had to take a moment here being in the homeland, and I just have to say, I love this phone. I love the Nokia Lumia 920, and I have to take a quick moment to take advantage of that. I got to take a picture because my wife likes to know. She's like, what's it like up there? And especially my children. I've got a 9-year-old and an 11-year-old right now, and they always ask me, Daddy, what's it like up there? And I said, you know what? I can't think of a better time to pull this out and take a couple pictures and take advantage of the nice optics in this camera. So I just wanted to do that. Thank you very much. There is a tremendous amount of change going on these days. Cloud, virtualization, is it on-premise? Is it somewhere else? Is it a combination of the both? Is it Microsoft? Is it a service provider? Is it a partner I've been working with? Is it something I deliver myself as an infrastructure as a service? Lots of questions. And what I wanted to talk about today was really to talk about the private, public, and hybrid cloud. I want to be very clear about something. I only have 90 minutes. I could literally be here up all day, and I still would barely scratch the surface of what's new in Windows Server 2012 and System Center 2012. So I do have a session later where I'll go deeper into Server 2012, but I just want to be very clear, as much as I tried to cram in here for this keynote, there's simply not enough time for me able to deliver. This is a monumental release. Let's talk about some of the transformational trends we're seeing. Cloud computing is huge. What's been amazing to me is I've been watching this happen for a very long time. I've been working on virtualization now for over 15 years. I just celebrated my 10 years at Microsoft, but before Microsoft, I worked at a small startup in California. Back then, we made a product called Virtual PC. Back then, people wanted to run Windows 3.1 and DOS on their Apple Power Mac 6100, 7100, and 8100. It wasn't just virtualization back then. It was actually far more difficult. It was virtualization in binary translation because we had to convert from x86 to PowerPC and back. That was very different than where we are today. Now we're talking about virtualization as simply powering the cloud, powering the world, powering infrastructure as a service, and powering everything. We see it used pervasively. We use it everywhere at Microsoft. Everywhere we're using virtualization. Some very, very obvious. Others, you have no idea, but you're using it right now. Virtualization is literally everywhere, and cloud computing is changing this because now we're talking about usage-based. We're talking about consumption-based. You could now be a single developer that says, you know what, I would like to develop something that needs literally 10,000 cores. You could never do that as a single developer in the past. You couldn't afford that. Now you're talking about, you know what, I need it, I'm going to get some cloud computing. I'm going to get some crazy amount of compute memory horsepower and do some amazing things with cloud computing. It's providing enormous agility to deliver new workloads faster than ever, better than ever, with better resiliency, better uptime, better security. There's a lot to offer in cloud computing. Data explosion. This could not be more true. We're talking about a crazy amount of storage every year. I believe it's over 40% of the world. We're seeing an increase of storage 40% year over year. Where are we putting all of this? Okay, it's amazing how much content we're delivering. And why is that happening? It's happening because of this. The consumerization of IT. The fact that people expect to be able to use any device, any platform, anywhere, and access their stuff. My music, my videos, my data, my personal, my work, and I expect to be able to get it all from anywhere, at any place, at any time. I just expect this to all go with me. I want to be able to synchronize it. So guess what? I'm using it at home, and guess what? It's available when I go on the road as well. So how do we handle all of these different paradigm shifts that are happening? And of course, there are new social and app patterns. Now we expect, you know what, I need an application, by the way, that runs on my phone. I want a similar context on my tablet. I want a similar context on my desktop, my PC, whatever that form factor is. And somehow, by the way, if you're an app developer or if you're an IT pro, people may want to scale this to crazy heights, to be able to scale this throughout the country, throughout your region, throughout your continent, throughout the world. How do you enable workloads and how do you enable applications to do this? Compute, storage, and networking. It's amazing to see what is going on here. Compute, I mean, it's crazy amount, the number of cores we're talking about now. Okay, we've had 8, 10 cores on a processor for a number of years now, and that's not even counting symmetric multithreading. That's not even counting threads. That's just talking about raw cores. So compute, we've actually had an enormous amount of compute for a long time. And in fact, honestly, in my opinion, compute hasn't been the problem for a while. Every so often someone says, hey Jeff, I'm thinking about doing infrastructure as a service, doing virtualization. Should I get the 2.4 gigahertz processors or the 2.8 gigahertz processors? Honestly, compute is the least of your problems. We're not compute limited. Okay, that just isn't the case. It's the other areas that are challenging to us. For example, I/O, storage and networking. I'll give you a big hint. As someone who lives and breathes Hyper-V, most of the time the hypervisor is waiting for storage. I get people asking me these questions all the time. You know, how do I know that Hyper-V is going to give me the performance that I need? Hyper-V is sitting around waiting for your storage 99% of the time. It's because we're waiting for that old disk to actually get around and give us the data we're looking for. Well, we're seeing some massive changes now in the industry around storage. Okay, the rise of SSD, to me, is like one of the greatest things. I feel like I've been waiting for SSD half my life. I was in my garage a few months ago, and I pulled out my old Atari ST 20 megabyte hard drive. It was the size of a shoebox, sitting in my garage. And I never forget when I bought this, I was in high school, brought it home, showed my mom, and my mom started screaming at me in Spanish. You spent $700 on a thing the size of a shoebox with a little blinky light on it? She had no idea what it was. She didn't care what it was. She couldn't believe that I'd spent $700 on that. But the thing that is amazing to me is that was 20 years ago. And guess what? That disk hasn't largely hasn't changed since then. What's inside there is a spinning disk with a read-write head that goes across a platter. Sure, the disks spin faster. We put more heads on there. The heads are more accurate. But disks largely haven't changed. In fact, if you go back to the dawn of the hard disk, back in the 1950s, hard disks looked the same. Yeah, they were a lot bigger. And the seek time was roughly a second. But guess what? We've gotten them smaller, we've gotten them faster, but we've still been limited by a read-write head. SSD changes this dramatically. SSD is, guess what? I don't need for a read-write head to go find it. SSD just, here's a whole bunch of data really, really fast. So we want to take advantage of what's going on there in storage. And of course, networking. If you look at the last 12 to 18 months, everyone's talking about software-defined networking, SDN. Everyone's been talking about, wow, this thing is going to be amazing. It's going to change the world. It's just brand new technology. No one's ever been doing it before. Except we've actually been doing it for a while. We know how important it is. It's how we deliver some of our global services, and I'll talk about that. So when we think about the cloud and the cloud OS, you know, let me be very clear about something, because I'm surprised at how many people, this is probably an area we need to do better about messaging, about how we think about the cloud. There's a number of key attributes about the cloud OS, and it transforms the data center. We can be much more efficient with virtualization, with how we use resources, by pooling resources, whether it's compute, storage, networking, and then being able to carve those up in a very efficient way. To be able to do that with a high quality of service, to deliver to a service level agreement. Enabling modern apps, to be able to deliver apps that scale to any size, any environment. Unlocking insights on any data. We are seeing we are gathering a tremendous amount of data. The problem is, how do we actually parse this data? And you know, we get all of this data. Where can we parse a huge amount of data, and how can we do it in a most efficient way? We can actually change the world in a very, very big way if we could just figure out how to parse some of this data. I'll talk about that a little bit later. And empowering people-centric IT. So what makes the Cloud OS unique? Flexible development. We want to give you expect to be able to, as you saw just earlier, I want to write an application that, guess what, it works on a phone, works on a tablet, it works on a desktop. I have a consistent interface. Something that allows me to take advantage of natural user interface. Okay, the mouse and the keyboard are nice, but touch is everywhere. It's amazing. I got a Surface, brought it home, gave it to my daughters, didn't say a word, didn't say a thing, and they were just, that's it, they were good. Perry the platypus you saw up there, they found it. They went up to the store, they found it, they've been playing it. I walk in the door now, and it's like, hi, Dad, we love you, where's the Surface? So I've seen it. Touch is very much real, and the natural user interface is you're only going to see more adoption there. Common identity and security, absolutely. I want my identity to follow me. If I'm going to the cloud, I want to be able to take advantage of single sign-on. I don't want to have to be having to deal with, well, how do I deal with authentication? How do I deal with security because I've moved to the cloud? Let's take advantage of Active Directory, both on-premises and in the cloud. Integrated virtualization. Hyper-V is part and parcel of the platform. And you heard it mentioned earlier, and I'll say it again. Hyper-V is what powers Windows Server. It's what powers Windows Azure. And we've made huge investments. And I'll talk about that today and more in my deep dive. And complete data platform. So let me talk to you about how we think about the Cloud OS. So take a look at the cloud above there. We kind of think of it as really 3 legs of a stool, where each one of them is unique. Each one of them has its own tremendous key characteristics that all actually work together in concert to provide the best Cloud OS experience. So what do I mean by that? Well, where has cloud started? It's all started in the private cloud. You, the customer. Me, the customer. The person who's actually developing their own private cloud infrastructure. Why has it started there? It started as an outgrowth of virtualization and consolidation from the 90s. I saw this firsthand. It was amazing. In the 90s, the answer, it seemed like, to every problem, go buy another server. Servers were cheap, servers were easy, servers were inexpensive to set up. I worked in a small startup, and I saw it. We were a small company, and we had servers coming out our ears. And we just kept buying more. It was really, really cool, really easy to use. But guess what? Eventually, you reach a point that, you know what? I have no place to put these. I have no power to power these with. I spoke with folks in Chicago high-rises and New York high-rises that said, Jeff, I have plenty of budget. I can still buy more servers. I can't manage them. And so virtualization grew as a way to consolidate these. Let's take 10, let's take 20 of these, let's virtualize them, let's put them on a single server. Even if I have a very conservative virtualization, five physical machines to a single server, I've done a tremendous amount of consolidation. But what happened is, as we moved to consolidation, we didn't change the management paradigm. So what happened was, yeah, I had a whole bunch of physical machines that I virtualized, but when they were physical, how did I manage them? I went to the box, I logged into it, and I made some changes on it. I went to this box, I logged into it, and I made some changes on it. I then virtualized them, and how did I manage them? The same way, the same very inefficient way, which is when I need to make a change, I go log into a VM and make a change on it. If you're doing that, if that's how you're managing, that's virtualization. That's not cloud. There's nothing wrong with that. There's absolutely nothing wrong with that. But let me be very clear. That's not how we think about cloud. I want to be able to write an application and say, you know what, this application is going to elastically grow based on its demand. I'm going to give it policy and say, you know what, you have a minimum of this amount of cores, this amount of memory, and this amount of storage. And you can grow as high as this much. Or I just give you an unbounded end if you'd like. If you want to run this on Azure and just consume as much as you need, go for it. But that's how I want to do it. I want the application to grow elastically based on its needs, not, hey, let's go into a VM and go manage it individually. So customers started doing this in terms of private. And the reason why you did it in private, one word, control. I speak to customers all over the place. I was in Canada, I was in Australia, and very often they'll say to me, you know what, Jeff, I love what you guys are doing in the public cloud. Azure looks amazing. Office 365, fantastic. I love all of this. However, we have a little problem. I have a couple workloads over here. This workload has to run in a data center on Canadian soil by a Canadian citizen. So no matter what you tell me, no matter how cool it is, I'm still going to run this on my premises. No problem. Happy to do that. That's Windows Server and System Center. We're absolutely happy to do that. Now, if you then look at the next one, is Windows Azure. In Windows Azure, it's about scale. With Windows Azure, you can write an application, develop an application, and guess what? Maybe it's available in Europe. And guess what? You know what? This worked out great. Let's check a checkbox, and now it's available in Asia Pacific. Let's check another checkbox, and now it's available in North America and South America. And guess what? When you're writing for Windows Azure, you get to take advantage of the global scale, the global resiliency, the capabilities. It's platform as a service, software as a service, or if you just want a VM, we have the VM role. We give you infrastructure as a service. So we give you that as well. And then finally, service providers. Because again, we see all of these three together. Service providers give you reach and customization. We work with service providers all around the world. In fact, when I was in Australia a few months back, I found out there's a whole bunch of mining going on in Central Australia, northern Central Australia. And there's literally folks that leave college and they go to this the central part of Australia and do a bunch of mining. They're getting minerals and ores out of the ground. Guess what? There's nobody out there. It's literally the bush, as they say. There's no cell phone service. It's satellites. They still need computers. They still need internet access. So there are service providers that are giving them that unique reach. And that's something that service providers offer. So one of the things we know is we know how to run global services with over 200 global services around the world, whether it's Office, Xbox Live, Bing, MSN. One of my favorite statistics is during the week of Christmas, Xbox Live will deliver over 5.5 petabytes of data during 1 week. That's how crazy it gets with everybody unwrapping all their new Xbox games and taking advantage of Xbox. On an average day, we deliver over 10 billion instant messages. So we know global scale. And what's great about this is we take what we learned in Windows Azure and our global services, and we feed those requirements back into Windows Server. And then in Windows Server, we make those into features, and we feed those back into Azure. We call this the virtuous engineering cycle, the virtuous development cycle, because one is learning from the other. And we learn a lot in running our own global services. In fact, one example is the fact that we've been using Hyper-V for a very, very long time at global scale. So for example, if you've ever been to technet.microsoft.com, we get over 1 million hits per day. If you've been over to msdn.microsoft.com, we get over 3 million hits per day. This has been running off Hyper-V for years. For years. And in fact, it all went so well that we power MSDNs, Connect, Social, Codeplex, et cetera, et cetera, et cetera. But the big one, the largest virtualized website we know of on Earth, is Microsoft.com itself. So if you've ever been there, yeah, guess what? You're hitting Hyper-V all the time. For over 5 years. We get over 15,000 requests per second. So in the time it takes me, powered by Hyper-V for 5 years, we've had about 60,000 hits on the site. We get over 40 million hits per day and 1.2 billion page hits per month with zero downtime. This all started, Hyper-V deployment, with the beta release of Hyper-V way back in 2008. And we just continuously upgraded, and of course, it's all now running on Server 2012. So, the Cloud OS. We look at it as having, again, some very key and core tenets to it. Transforming the data center, enabling modern apps, unlocking insights on any data, and empowering people-centric IT. Let's walk and delve into each one of those a little bit and talk about, and then I'm going to demo these and how these are delivered in what we've done in Server 2012 and System Center 2012 SP1. So scalable and elastic. Like I mentioned before, the whole virtualization paradigm of consolidation and management was all about, look, I took a whole bunch of physical servers, I virtualized them, but then I treated them the same way as when they were on physical. I go log into a machine and I make some changes. Okay? We want them to be scalable and elastic. I want to define a policy for an application. I want it to be robust and rich. Shared resources. Obviously, I want it to be able to take advantage of how I share my resources, whether I'm pooling my storage, whether I'm pooling my network, my compute, my memory. Share them, of course, in a multi-tenant environment. Of course, this also means implicitly that I've got to provide multi-tenancy. Always up and always on. This, to me, I'll never forget when my youngest daughter, Olivia, she was about 5 years old. And I'll never forget, one of the things she liked doing was going to sesamestreet.com. And she would play a whole bunch of little education games there. And she said, Dad, can I play sesamestreet.com? So I went over to the computer and typed it in and clicked it on it. And I said, there you go. And I started to walk away, and she goes, Daddy, it's broken. What? I turned right back around. I walked over, and I looked at it. And by the time I walked back over there, then it came up. But it was like immediately the light switch had been clicked. My daughter, 5 years old, looked at it and says, if it's not here right now, immediately, this very moment, Daddy, it's broken. Okay? If you're an IT pro, the job's getting harder every day because that's what people expect. If it's not happening right now, it must be broken. Whose fault is that? We've got to enable always up, always on. That needs to be available at every part of the stack, whether it's storage, whether it's networking, whether it's the resiliency of the platform, whether it's cross-platform, cross-rack, cross-data center. You got to be thinking about this at all different levels. Automated self-service. A key part of cloud is for the ability for someone to go in and say, look, I want to do this myself. I just need a couple VMs. I don't need to go to IT for every single request. What I'd really like is give me some prepackaged VMs that I'm ready to go with. And by the way, automation is key. We've made some huge investments in automation, manageability, in Server 2012. Here's a key tip for you. If you're an IT pro and you want a long career in IT, make sure you have PowerShell on your resume. I'm telling you right now, if you don't, the guy sitting next to you does. Okay? In Server 2012, we delivered over 2,300 PowerShell commandlets in the box. Okay? Compare this to 2008 R2, which had 150 total. Okay, we're talking over 2,300. Hyper-V alone has over 150 PowerShell commandlets. So we've done a tremendous job to make it easier to script and automate servers in all aspects of server. So let's start with how we think about enterprise class scale and performance. One of the biggest things we did was before Server 2012, went to customers all over the world. And we said to them, we want to hear all of your problems. We want to understand what are the things that we need to solve. And one of the things that came up over and over again was, Jeff, real simple. I've already virtualized my print, my file, my departmental apps, my legacy line of business applications, but I got this monster workload over here. This thing is huge. This thing requires dozens of cores, hundreds of gigabytes of memory. It's attached to my SAN via fiber channel. It's using MPIO. It's using NIC teaming. It's got two 10-gig NICs into there. I want to be able to virtualize that thing too. In fact, quite simply, I want to be able to virtualize everything. Okay, it's a tall order. We heard you loud and clear. In Server 2012, we simply redefined performance and scale for virtualization, and we lead across the board. On a physical server, we support up to 320 logical processors per server. To put that in perspective, that's a 16-socket server. Each socket has 10 cores, and you enable symmetric multi-threading. It's a big box. Even without it fully populated with memory, it's over 100,000 euros. It's a very big system. Okay. On top of that, that's the physical in terms of compute. In terms of memory, we support up to 4 terabytes of physical memory. So you can see you can pack this thing up and run a whole bunch of VMs. Well, in terms of virtual machines, we made some huge improvements there. Massive scale there. Up to 64 virtual processors per VM. Up to 1 terabyte of memory per virtual machine. So look, with all of those changes, we can now virtualize the biggest, baddest workloads you have in the industry. In fact, with those changes and coupled with some massive performance and I/O changes we made, we can easily virtualize over 99% of the world's SQL server. So let me be very clear. We can virtualize whatever you got. I haven't seen an app yet that I can't virtualize in 2012. Okay? So, talk more about this later, especially in my deep dive session today. I'll explain how we did this. I just don't have the time right now. Virtualization across compute, storage, and networking. This, to me, is really super cool. Because not only did we look at the hypervisor, we've been doing virtual machines for quite a while now. We looked beyond that. Network virtualization, storage virtualization. That's in the box too. One of the biggest challenges we have today is people think about, I showed you our cloud and how we think about it having three parts, the public service providers and your private cloud. Well, what happens when you want to enable a hybrid scenario where you basically want to take your workloads and move them to a service provider or move them to Azure? What you really want to do is you also want to take your network with you, because you want it to appear like one big network, whether it happens to be running in your data center, maybe in your secondary data center, maybe in a service provider. You want that to appear as one big logical network. And of course, it's got to be logically segmented. You're going to see all of your stuff, and you're not going to see any other tenants. So network virtualization is key. And in fact, if you look, that's one of the reasons why the guys over at VMware spent $1 billion to buy Nicira. Why did they do it? Because they realized we've already put it in the OS. We're done. They're a couple of years behind us and realized we need to do something, we need to buy something, and we need to try and figure out how we can integrate it quickly. We already put it in the OS. It's built into Server 2012 right now. And then you manage it with System Center, because that's how you do your holistic management. So we have network virtualization already in the box. And then we have storage virtualization with Spaces. So we can take your storage, you can put a whole bunch of disks, we can pool it, and then we can carve it up. And you can even add disks hot on the fly. And I'll show you this in a little bit. And of course, continuous availability with management efficiency. We've made huge changes in clustering, the scale of clustering. It's massive. In fact, very quickly you can see 64 nodes and up to 8,000 virtual machines in a cluster. This is industry-leading cluster scale right here, all part and parcel built in Server 2012. And when it comes to virtual processors, by the way, here's 32 virtual processors. I specifically took this screenshot with Windows Server 2008 R2 to show you that it works on down-level operating systems. And in fact, here it is on Red Hat Linux to show you that, yes, folks, we're very, 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 very making big investments in interoperability and making sure that, guess what? Hyper-V is a great platform for your Linux. Whether it's Red Hat, CentOS, SUSE, Debian, Ubuntu, et cetera, et cetera, et cetera. There's your 32 virtual procs. And by the way, here's 64 virtual procs, a terabyte of memory running a massive SQL OLTP workload under massive scale. So we're doing it. So CloudOS also has to enable modern apps at cloud scale, flexible and easy, hybrid and extensible, with a rapid dynamic life cycle. So what do I mean by that? First of all, you want the flexibility to build on premises and in the cloud. So say, for example, I want to build that application, or I've already built it today and it's running in my private cloud today. Wouldn't it be great if I could just take that and move it on up to Azure and it just worked? Guess what? That's exactly what I'm telling you. That's what it means to have a consistent virtualization platform and give you that consistency so you can do exactly that. You can take your virtual machines and move them to Azure and give you that consistency there. Open web and app development environment. Let's be very clear. You saw it if you were here in the session before, talked about, certainly we love .NET, but let's also be very clear. You want to run Java, you want to run Ruby, you want to run Python, you want to run, insert your platform here. We make sure that Windows Server and Hyper-V is the best platform for all of these things. We want to make sure you've got the best experience out there. Finally, scalable and elastic infrastructure. Whether it's one node, whether it's 16 nodes, whether it's 32 nodes, let's give you an application that you build your application and it builds and it actually expands and dynamically expands and contracts based on its usage. Let me actually give you a perfect example of that. Perhaps you've heard there was a couple of books written about some guy named Harry. He's a wizard or something like that. J.K. Rowling wrote the Harry Potter books, incredibly successful. My oldest daughter was reading them these last couple of years. She just reads them over and over. She just loves them. And I think they're fantastic. And one of the things that J.K. Rowling wanted to do was a huge thank you to all of the fans of the Harry Potter books. And so she wanted to do something unique. She wanted to do not just a website, but something really immersive. Something that had unique content, illustrations, artwork, videos, interviews, things you'd never seen in the movies, things that weren't in the books, things that she wanted to deliver just as a huge thank you. So she wanted to basically build Pottermore. Well, one of the challenges was capacity planning. Think about this for a second. Someone comes up to you and says, hey, by the way, I need you tomorrow to go build Pottermore. How big is it? How much hardware do you buy? How much compute do you buy? How much storage do you buy? How much networking? Honestly, I have no idea. When I heard about this, I can only imagine a bunch of guys got in a room and said, we're going to buy a whole bunch of hardware and we're going to do one of these. And we think that looks about right. We think that's about right. We don't know, though, because she's got a huge following literally around the world. So what they did was they turned it on. And Pottermore attracted 1 billion page views in a little over 2 weeks. More than 10 million unique users. The average user visits 43 pages and spends 20 minutes on the site and continues to basically account about 25,000 new accounts daily. I don't know how you do capacity planning for this. In my wildest dreams, I would not have known how to do this. So they set this thing up, and in fact, they started with a private cloud. That's how they started it. And it just, they had to stop accepting new users. They could not take this demand. So they had a couple of options. One of the options was, we can just buy some more hardware. We can buy some more storage. We can buy some more networking. We think we may get it closer, but we're not sure. Well, you know what we decided to do was, let's move this up to Azure. It started on premises, but customer demand just simply blew that away. Well, no problem. Move this up to Azure. Guess what? Turned it on Azure. You need more? Oh, there's more people going. Boop, 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 boop. It just grows. Oh, there's more people today. Boop, 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 boop. It just keeps growing. Keeps growing. Boop, 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 boop. It just grows. And guess what? When it's the holiday season and you know what, everyone's out shopping and no one's particularly on the web at that moment, maybe it contracts. That's usage-based. That's consumption-based. That's the elasticity you're looking for. That's how we think about cloud. It's not just a VM. If anybody's telling you a VM is the cloud, well, you know, when all you sell are, you know, nails, every problem, you know, you got a hammer. That's kind of the old story there. We look at this very holistically. And in fact, what happens is you then don't worry about the infrastructure. You focus on delivering the best application, on the best unique experience to your customers. That's what you really want to be focused on. So we're very excited and very happy that this has been working and continues to run on Azure today. So unlocking insights on any data. The data explosion is here. And like I mentioned before, everybody wants their data on any device, on any size, anywhere, wherever they happen to be. You want to connect with the world's data. There's a lot of data that's publicly available. Wouldn't it be great if you could tap into some of those data warehouses, provide an immersive data experience? So, number one, we understand that we want to provide a complete data platform. And we want to use the tools that you're comfortable with. One of the best tools out there for this is actually Excel. People know this. Or SQL, or Hadoop. In fact, we've been doing a tremendous amount of Hadoop integration, and you can download Hadoop integration tools for SQL Server 2012 right now. So we're making huge investments there. Integrated data reaching beyond your organization and analysis and insight with familiar tools. We want to make sure that you use the tools that you're comfortable with, that you're consistent with, and we're going to plug right into those, and we're just going to keep doing that. And I could not come up with a better example than this one. Here's an example, and I'm so proud of this type of work when we're working together with the research community. This is about literally making the world a better place, okay? This is about doing work on genome computation. So I literally wanted to read this because I knew I was going to get this wrong if I didn't. But David Heckerman in the eScience Research Group at Microsoft developed a new algorithm called FastLMM that can find new genetic relationships to diseases by analyzing data sets that are several orders of magnitude larger than was previously possible. So think about this for a second. We have a treasure trove of data out there. And somehow we want to analyze this and look for combinations and look for all of these subtle signals in the data that can help us prevent diseases. The research team turned to Azure to help them test the application. They used the Microsoft HPC pack with FastLM on 27,000 compute cores on Windows Azure to analyze data from the Wellcome Trust study of the British population. They analyzed 63 billion, 500 million pairs of genetic markers, looking for interactions among these markers for bipolar, coronary artery disease, hypertension, inflammatory bowel, Crohn's disease, rheumatoid arthritis, and type 1 and type 2 diabetes. I can't think of anything more important and I'm glad to hear that our research guys are helping with. This is tremendous. Well, what are the results of this work? Well, the results were over 1 million tasks were scheduled by the HPC PAC in over 72 hours, consuming the equivalent of 1.9 million compute hours. To put that in context, that same computation would have taken 25 years on a single 8-core server. Did that in 72 hours. Think about that for a second. Think about bringing these amazing resources to bear to analyze data in a way we simply never could have done before, even 5 years ago, even 10 years ago. It's amazing what we have at our disposal. And so we've dramatically improved the ability to discover new associations between the genome and these diseases that could help in potential breakthroughs for prevention and treatment. So this is just one way. We think about cloud in so many different ways. Certainly it can be retail. Certainly it could be, hey, I want to develop an application. A personal developer. Certainly can help my IT pros be more efficient, do more with less. Or we can take advantage of this huge compute power that we have that the cloud affords us and really try and actually and literally change the world. By the way, the HPC PAC, I figured a number of people may ask about it. It was released a few months ago. If you want to check it out, just do a Bing search on HPC PAC 2012. It's publicly available. You can download it now. So, finally, the Cloud OS empowers people-centric IT. It's about a personalized experience. It's about any device, anywhere, and of course, secure and well-managed. The secure and well-managed is an interesting one because we certainly know that everyone's bringing in all sorts of devices into work, okay? And there's nothing wrong with that. The whole bring your own device movement, you know, some people want to bring in their own laptops, some people want to bring in their phones, their own tablets, et cetera, et cetera, et cetera. There's nothing wrong with that, but you do have to be careful. You can't just bring in any random device for the sake of, you know, making everyone happy at the expense of potentially introducing security risks and vulnerabilities into your infrastructure. You do need to think about policy and governance, even on bring your own devices. For example, a real simple one is, look, if I'm going to be using my awesome phone, my personal phone at work, and getting work email, my phone locks in 60 seconds. Actually, maybe even less than that. To make sure that if I do lose my phone, guess what? You know, it's locked out. Everything is pin-coded. I can do remote erases. So things like that, they sound very fundamental and very easy, but you still need to be able to do that. People bringing in all sorts of devices that, oh, by the way, they downloaded a random ROM and decided to, you know, flash their tablet and do some interesting things with it. And maybe that's good, but maybe it's not so good. So you need to be able to provide policy and governance for all of these different devices. So when we think about empowering people-centric IT, certainly it starts with identity and authentication. Whether I'm running it on my premises, I log into Microsoft, I log into my account, I log into my domain, I have access to what I have access to as a principal program manager in the Windows Server and Cloud division. I can't see in other organizations. They can't see into my organizations. Oh, by the way, if I want to go up in Azure, I want to take that identity with me. That's fantastic. I want that single sign-on. And if I want to federate between sites, I want to be able to take advantage of that single sign as well. Dynamic access control, very important. One of the things that we found out when we were doing Server 2012 development was we sat down with a bunch of security analysts, a bunch of security experts. And these are the guys that go in, usually a company will pay them, to do a security analysis of their infrastructure. And one of the things we heard time and time again were file shares. Everybody knows how to set up a file share, or file shares get set up all over an infrastructure, and guess what? People put random data out there, and they forget that they put them out on a file share. Turns out it was actually really super important data that should have never been on a file share in the first place. For example, I need to give my boss an Excel spreadsheet, and that spreadsheet happens to have, oh, I don't know, payment card information in there. It's got credit card information, or IRS tax information, something uniquely confidential, but I just stick it up on the file server. You know what? I need to get this to him. He'll download this, and I'll remember to delete the file share on Monday. And then Monday and Tuesday go by, and guess what? It's totally gone. I forgot, but it's still sitting out there. At the same time, you've got people, you've got contractors, you've got anybody who happens to get access to your network, who happens to start looking around for file servers. Wow, look what I found. Look at the data I found. Wouldn't it be great if there was a way to help IT pros protect against this type of issue? So, for example, dynamic access control is a capability coupled with file classification to help you with this exact type of problem. For example, I could take an Excel spreadsheet, and I could say, I'm going to put it on a file share. Well, when I put it on the file share can look inside the spreadsheet itself. I write a policy, and it looks inside and says, oh, I see credit cards. I see social security numbers. I see finished tax ID information. Guess what? I'm going to automatically encrypt this document. The IT pro doesn't have to do anything. You just write the policy, okay? You write the policy, automatically does the right thing. So even if someone happens to be on your network, they can't get access to the data. All completely automatic. Comprehensive VDI solution. We made some huge changes around virtual desktop infrastructure and the remoting in Server 2012. For example, you want to be able to take advantage of RDP Remote FX. In the past, RDP, the Remote Desktop Protocol, we now call it Remote FX, it was a great solution for LAN. Okay, if you're on the network at work, got a great solution. But if you wanted to do it over the WAN, couldn't do it. We just couldn't do it. Well, that was something you told us repeatedly. Please, Microsoft. That's exactly what I want to do, because I've got users all over the place from now. People are working more and more in home or on the road, and I want to give them a rich environment, a rich experience remoting back into work. And I want to be able to use it using Server 2012 and the inbox remoting protocols. So we did exactly that. So let me jump on over here. And in fact, let's switch on over to the demo. Thank you. Can everybody see that? Great. In fact, just to let you know, speaking of remote desktop and the remoting protocol, this is all in Redmond, by the way. This is all happening very long hop. I couldn't bring all the hardware with me if I tried. So let's take for a moment, I'm going to show you a couple of different scenarios here. Let's suppose for a moment this is a bring your own device type environment. This could be my Surface RT, this could be my personal PC that's not domain joined. Okay? I'm simply a work group. I just happen to bring in my machine from home. I really love this machine, and I like to use this one with me. It's my favorite. Okay. But at the same time, I still need to access from time to time corporate resources. I still need to access those applications that I need to do my business. And in fact, if it's a Surface RT, what if the application doesn't even exist for RT yet? It's only an x86 application. So let's head on over here to remote desktop for a second. And you can see I've got a number of applications over here. I'm just going to jump into Excel because I just happen to have a spreadsheet I want to show you guys. But what you're seeing here is remote app. Now, remote app uses the remote desktop protocol. It's using what we call remote FX now. And what you're seeing here is it's presenting the application. It's not presenting in a desktop. It's just presenting the application. So even on a non-domain joined machine or on a Surface RT, it just all works. It's all running server side. I'm getting the application remoted to me. Now, over here, I happen to have a capacity report I've been looking at. And in fact, I've been running some analysis on some servers in my infrastructure, and this is actually pretty important data. I would not want this getting leaked out. So you'll notice up above here, you'll see this has high business impact. So this thing is actually being automatically encrypted up on the file share. And since I'm the author of it, it's not a problem. I have full permission to do everything I want. I can view, edit, copy, print, save, etc. But I have the granularity to make those changes to different groups based on business policy. So what you're seeing here is application looks like it's local, acts like it's local. It's all actually all running remote. So I can see here, whoops, I've got a number of things in terms of my virtual procs, my memory, my storage. I'm actually pretty over, I'm in the red line here. So I want to go in here and actually now realize I need access to a full desktop. Okay? I need to actually go in there and make some changes. So you'll notice that this background is green. And the reason why I chose it is because you can see this is my personal desktop. This is what's running on my non-domain, my work group machine. And let's go back to remote desktop. This time, I'm going to remote, and I want to get a full, rich desktop. So now what I'm doing is I'm clicking in here, and lo and behold, here's my full desktop. Now, what's different is, let's go back over here, and you can see this only has my work apps. Okay, this doesn't have any of my fun stuff because this, again, is my corporate environment. So you can see it's very different. In fact, the apps in my taskbar are very different. So before I jump into Hyper-V, let me talk to you about storage for just a minute. I mentioned that we did a variety of different types of virtualization in Server 2012. We've been doing Hyper-V and virtual machine virtualization for a while. We've introduced network virtualization. But the other one that we also introduced that a lot of people may or may not have heard about is storage virtualization. And we did that with spaces. And the whole concept of spaces is that you can provide a whole bunch of raw disks. You don't need anything special. Just give me a whole bunch of JBODs, just a bunch of disks. And what we can do then is we will pool those, and then we can carve those up with different resiliency type of capabilities, whether it's simple, whether it's mirroring, whether it's parity, all using spaces built into Server 2012. So for example, I'm going to go on here over to File and Storage Services, and you can see I've got a variety of storage pools. And in fact, you can see I've got one that's running here in the red line. So what I would like to do is I'd actually like to increase the capacity of this storage pool. Well, in the past, what are you talking about? You're going to take the machine down, you're going to add some disks. Well, in this case, I'm simply going to right-click and add a couple of physical disks. So you can see I've got 2 disks. In fact, I'm going to add them both. And one is going to be available now, and I'm going to make the other one a hot spare in case I need it for later. And I'm going to click OK. And you can see with spaces, again, we have virtualized storage. So now I've added physical disks into my virtualized storage pool, and now I've done this all hot. And guess what? That capacity automatically appears here. So I went from a red line operation to, hey, no problem, I got plenty of space here available. So that's one of the beauties of storage virtualization. So let's head on over here. Let's go back on over to here, and let's go on over to Hyper-V Manager. So I'm going to start here first, just so I can show you some of the things that we've done with the inbox utility. Okay. So you can see I've got a number of virtual machines. Whoops, hold on here. Helps if I press the right buttons. Okay, so you can see I've got a number of virtual machines here. And what I'm going to do is I'm actually going to drop into the settings of one of these VMs to show you a couple of things here. So I mentioned earlier on, we made a whole bunch of changes in terms of scale. Well, this initially was a SQL server that I was developing for Windows Server 2008 R2. Windows Server 2008 R2 Hyper-V maxed out at 4 virtual processors. Well, Server 2012, I can go a lot higher. In fact, in this case, I'm going to take it all the way on up to 16. That's as many as I have in this machine. This is a dual socket machine with 8 logical processors per socket, so I've got 16 virtual processors I could assign to this. So I'm going to go right ahead and do that. By the way, I should also point out we've made some huge changes in terms of storage. So one of the things that customers told us, I mentioned this earlier, was customers said, you know, I got this big workload over here. This workload requires dozens of cores, hundreds of gigabytes of memory. But it also requires access to my fiber channel SAN, because that's where all of the data lives from my big scale-up SQL server, right? Well, guess what? Look what we have here in Server 2012. We have honest-to-goodness real fiber channel. So I'm going to go ahead and add a fiber channel adapter to this VM. And you can see here, I could go in here, edit the addresses, and zone and mask worldwide node names, worldwide port names, exactly the same way you would a physical machine. This is extremely important. Okay? There are a number of ways you can implement virtual fiber channel. There's the right way and there's the wrong way. This is the right way. And what I mean by that is our virtual fiber channel, number one, this is real fiber channel. This isn't some sort of made-up fiber channel or emulated fiber channel. This is real, honest-to-goodness fiber channel. So it means you want to run things like guest clustering to fiber channel, no problem. You want to take advantage of multipath I/O to give you resiliency and redundancy for your storage going to your fiber channel, not a problem. You want to live migrate, all of this just works. You zone and you mask it exactly the way you would your physical infrastructure. If you want to run DSM software like EMC PowerPath, for example, just runs flawlessly. So that's one of the key new capabilities when it comes to block storage that we implemented in Server 2012. So let me head back on over here for just a moment. And, oh, actually, I wasn't done yet. Let me go back here. And let's head on over to memory for a second. One of the nice changes we made in memory was dynamic memory has been one of the great things we introduced in Server 2008 R2SP1. We made some additional changes to it. One of them was the ability to make changes on the fly. So for example, if I want to make changes to this, hey, you know what, I'm going to make these changes while the VM is running, I can hot add and change dynamic memory on the fly while the VM is running. So that's there as well. You can also change the prioritization for dynamic memory while a VM is running, all on the fly. So this allows you to be much more flexible and elastic about the memory requirements for your VMs. Then there's networking. And quite honestly, we made a huge, huge investment in the virtual switch and in virtual networking in Server 2012. I'm going to go much deeper into this later into my deep dive, but the one thing I wanted to point out was this first one here, quality of service. If you're an enterprise or a service level provider, this thing is critical right now, this new feature. Think about quality of service. If you're a service level, if you're a cloud service provider, this is how you make money. Okay? Because you charge, maybe someone gets bronze level service, and with bronze level service, they get up to 10 megabits per second. With silver level service, maybe they get up to 25 megabits per second. Maybe gold level gets them up to 50 or 100. You define that here, and we'll provide that quality of service based, which allows you to meet your SLA. If I'm an enterprise, this is actually really important for me. So for example, let's suppose for a moment I've got my SQL server over here. My SQL is really important. This is what runs my business. This thing can never be waiting around for the network. On the other hand, I got the guys in the graphics department that like to print out these huge, huge posters every Friday on the plotter, and they like to consume a whole bunch of networking. So honestly, those guys can wait. If it takes a little bit longer to print, that doesn't bother me. My SQL can never wait. So with quality of service, for example, I could say that for SQL, you know what? I'm going to make this 512. Whoops, if I can type. Make that 512. So that means my SQL server gets at least a half a gigabit NIC at all times. Very cool. Okay, that's awesome. Now, again, there are those guys that are over in the printing department, and I can do the opposite for those guys. I could say, you know what? You guys, you can have up to 100 megabit. That's your max. Okay? It may take you a little bit longer to print, but you're not going to saturate the network with a whole bunch of printing. Okay? I'm going to be careful about my network resources. So quality of service, a key capability, simply built in to the included virtual switch in Server 2012. So definitely want to make sure you know about that. All right. All right, so now let's head on over to System Center. Now, one of the things I wanted to do was just show you some of the things built using Hyper-V Manager. Hyper-V Manager is the built-in inbox management. It's very nice, especially for some small environments. But as you start to deliver at a larger scale, you got a number of hosts out there, you're going to want to be able to do things like templates. You're going to want to be able to do things like really do cloning, template, automation. You're going to want to be able to create services. Services are a combination of VMs put together. So instead of just a single virtual machine that's, say, a print server, What if I wanted to set up a service, which is, a typical 3-tier application, and define that service and deploy that service? The System Center is what gives you that ability to do that. I also mentioned the importance, I showed you storage virtualization. Now let's talk about network virtualization. So I'm going to bring up a little tool here. So you can see here, I've got my Fabricam hoster, and I've got Contoso Corporation. Oops, let me actually make it so you can see it. So I've got 2 different environments, and in fact, I've got Contoso Production, which is where I've got a number of VMs running here. So I've got a whole bunch of VMs running here in this environment, and I've got my hoster. And in fact, I moved a bunch of VMs on over to my hoster, and what I did was, you can see that they're running on completely different physical subnets. So if you look here at Fabricam, I've got 2 VMs that I've already put up there. One of them is running 10.11.1.10. Another one is running 10.11.1.9. And you can see there's the physical subnet. They're on 172.17. Now, why is this important? Because with network virtualization, what I really want to be able to do is I want to be able to move virtual machines from one location to another. I want to be able to move to a hoster. Maybe I want to move it back. Maybe I want to move to a different service provider. I want it to be done on my terms, though. And providing me that connectivity, oh, and by the way, I want to do this as seamless as possible. I don't want to have to, if I move this up to a hoster, have to change that IP address. Or if I want to bring it back, have to change that IP address. Another challenge, and one of the biggest challenges out there, is how do you live migrate across physical subnets? You can't. There's actually no way to do it. By changing physical subnets, that is by definition going to result in a break in transmission. Well, not with network virtualization. We've actually solved that problem. So I'm going to head on over here, and I've got a VM over here, and I'm simply going to drag it and drop it. So this is running on Fabricam right now, and this is going to bring up the intelligent placement wizard. So when you do live migrations with VMM, it makes sure, hey, do I have all the resources necessary in both places? It does a little pre-flight check to make sure everything's good, and it says, in fact, yep, you've got 4.5 stars here, you're good, let's go ahead and migrate the VM. So while that's migrating, let me show you, let's go right over here. Take a good close look. So the VM is running on Fabricam, and it's running on 172.17.1.53. And look at its IP address, 10.11.1.9. This IP portability tool is basically, we're getting notified when VMs move, and we'll be notified when this live migration continues. This is taking advantage of a whole bunch of new mobility features, and it's taking advantage of network virtualization. For example, one of the great new capabilities in Server 2012 is shared nothing live migration. With shared nothing live migration, I can literally migrate VMs from one server to another with nothing but an Ethernet connection. No SANs, no clusters, no shared storage. It's a mobility option. And in fact, you can see that VM moved, and you can see it just refreshed. Look at that. The virtual machine IP address stayed the same, but the physical subnet changed. And I live migrated throughout the whole thing. So now that you know what to look for, let me show you that one more time. So we're going to move the next one over so you can take a look at that. So I'm going to move this one Fabricam to Contoso. Intelligent Placement Wizards is going to say, hey, let me double check and make sure everything's good. We want to make sure you're going to have a successful migration. So it's checking both sides of the migration. It says, yep, everything looks good. So let's go ahead and begin that migration. Let's go back on over here to the IP portability tool. And again, the one you're looking at is WS 2012 DB01. It's 10.11.1.10. That's what's in the virtual machine. And look at the provider address. Now look, it's 172.17. Okay? As that live migration occurs, you're going to see it move on over to Contoso, and it's going to cross a physical subnet and do all of this live. It's almost done. You can see it's about 78% through, 79% through, 80% through. So network virtualization is simply built into Server 2012. There isn't anything else you need to buy. There isn't anything you need to purchase. And one of the important things about network virtualization I want to point out, there it is, it's actually done. And you can see it just refreshed. And there's the new provider address as it crossed physical subnets. One of the great things about network virtualization is it works with all of your existing hardware. That was actually a key engineering tenet. It works with all of your switches. It works with all of your NICs. It works with all of your routers. If this required, oh, you're going to have to go buy a whole bunch of new gear, no. People don't want to do that. They want to take advantage of what they have now. And network virtualization uses what you have right now. And it uses an industry standard, NVGRE. I just want to be very clear, because I've heard people say, is this a Microsoft thing? Is this some sort of special Microsoft thing? No. It's an industry standard that's been actually out there for quite a while. We're just taking advantage of it and actually using it. So when people talk about software-defined networking, we actually think of it as two key crucial parts of the technology stack. One, network virtualization, because it allows me to do things I could never do before. It allows me to take my virtual subnet into the cloud. I can go to a service provider. I can span multiple data centers that I own and create one big flat network. If I want to go up to Azure, if I want to go to service provider, it's all there. So network virtualization is at the core. The other key part of software-defined networking is the virtual switch in Hyper-V itself. We've done a tremendous amount of work. I just showed you one thing in the quality of service. We've done a lot more in terms of security, in terms of automation, in terms of teaming, and in terms of extensibility that I'll talk about later in the deep dive. So just to give you an idea, this is a major, major change across the board. All right, so with that, I am going to close that. And let's go back over here. And let's show you one more piece of the puzzle. So I've talked about how we think about the cloud in terms of on-premises, service providers, and Windows Azure. I thought, you know what, we better at least show you Azure and show you the VM role. We've done a tremendous amount of work here in Windows Azure. This is the current portal. And if you've been watching Azure over its growth and how it's been growing, this whole left-hand side just continues to grow and grow and grow with more services that are available to you. And I know tomorrow they're going to do a deep dive on the mobile services. Highly recommend it. But the one thing I wanted to talk about today was the virtual machines. So I get asked all the time, Jeff, this Azure thing sounds really cool. I get that I can build these applications that are new on top of your platform as a service. I get that Office 365 provides me finished services, that I can just start using Office applications and deploying them to universities, to municipalities, to my company, etc. But what about VMs? What if I just want to go up there and I just want to get a VM, you know, like the other guys? Well, guess what? The VM role is here. In fact, let's actually walk through the process of doing it. So let's create a new VM. I have to say, I really love this interface. It's really nice. It's really clean. It's very easy. It's actually very, I just want to go out and, you know, touch it here. So I'm going to go ahead and I'm going to create a VM from the gallery. So you can see I got a whole bunch of images here in my gallery. Now I'm going to click on platform images. These are all the images provided by us. Okay, these are the ones that are sitting up on Azure by default. Take a good long look there for just a moment. You see SQL, you see Server 2008 R2, you see Server 2012 Data Center. Whoa, CentOS. What's that? I thought this guy was from Microsoft. What's he doing with CentOS up there? And SUSE, as well as Ubuntu. Let's be very clear. We're doing a tremendous amount of work in terms of interoperability, and I'll cover this again in my deep dive later. But you can see it's right there. So if you want to fire up CentOS, you want to fire up SUSE or Ubuntu, go right ahead. I'm going to, of course, fire up my favorite one, Server 2012. And let's go give it a name. All right. Got to give it a password. Now, what's the size of the VM? Do I want a small core, medium, large, extra large, 8 cores, 14 gigs of memory? I'll stick with what I got right now. Small is good, thank you. Click on Next. I'm going to give it a name. All right. There's my virtual network subnet, my affinity. I don't need to do anything else there. I wanted to make it part of an availability set. I can. That's for additional resiliency. I don't need to do that right now. And click on Complete. And literally, there was a couple of times I typed in a name and a password, and there's my VM. It's being built right now, and it's being deployed right now. So you can see the provisioning process is in place, and this is happening. So if I want to take a look at an existing one, for example, well, here's an existing one I have already. This is a TCS demo one. And guess what? If I'd like to take a look at the dashboard and take a look at some of the information about this VM, I can easily, at a very quick glance and go, get a whole bunch of information about CPU, disk read writes, network in, etc., and a very quick glance of what this VM's been up to. If I want to go in there and take a look at monitoring and endpoints, I could do that as well. I also want to point out, I'm going to go back here for a second. And let's go there. You can see we've included all of the help right in here to make it as intuitive as possible. So if you'd like to know more about an overview, if you want to know more about Windows virtual machines, how-to guides for Linux, server software support, how do I do managing of disks and images, guess what? Click, we're going to bring you right into the documentation. We make it really easy. Guess what? Give you all the drill downs into Windows Azure up on TechNet and MSDN. All this is integrated. So you can see it's really all about creating this full picture, this very holistic picture of the cloud. If someone tells you that the cloud is, hey, it's building a private cloud on premise, that's one way to look at it. I know that there are some people that will tell you, no, you have to run a VM on my cloud, and that's cloud. Not really. Okay? Someone will tell you, no, it's only if you do software as a service that's cloud. No, again, that's a very myopic view of the world. We look at it holistically. We want to do what you want to do. If you want to do it on premises, go for it. And guess what? I'm guessing very soon you'll decide, you know what, I don't really need to do all of this on premises. Why can't I move some of this to the public or to a service provider? One question I hear all the time is, Jeff, in 10 years, is everything going to be on private or is everything going to be on public? And the answer is yes. Okay? It's a big slider. Okay? There will be plenty of customers that are all private or plenty that are all in public. Most people will be in the middle. Most people will be doing some combination therein, and we want to make sure we've got the best solution for you. All right, so let's go back. Let's switch back on over to the presentation, please. Guys backstage, back to the presentation, please. Thank you much. So one thing, and I wanted to talk about something very near and dear to my heart, disaster recovery. This is something, honestly, I've been watching very closely for a number of years, and this picture pretty much says it all. This is Hurricane Katrina. This is August 28th, 2005. This is the worst natural disaster in U.S. history. $110 billion worth of damage. Over 1,000 people lost their lives. Over 80,000 businesses were heavily impacted or destroyed. And to this day, people are still rebuilding in New Orleans from Katrina, still recovering. I grew up in California. In California, we have earthquakes. Earthquakes, you don't get much warning. It just starts shaking. You do your best. You try and find a safe place to be very quickly. Hurricane Katrina, we watched for an entire week. We knew it was coming. We saw it coming. We watched it on the evening news every night. We said, yeah, look at that. It's coming into the Gulf of Mexico right now. It's going right past Florida. It looks like it's heading right towards New Orleans. In fact, this is when we think it's going to happen. This is when we think it's going to land. And guess what? We were pretty close. Yet we watched it for an entire week, and still people lost everything. And honestly, that bothers me to no end. And I had a long sit down, and I said, why did people lose everything? Why are businesses, like literally, they can replace the brick and mortar, but they lost their IP? Why did that happen? Disaster recovery technology has been around a long time. It's been around for decades, in fact. Well, there's a whole bunch of reasons why people don't take advantage of DR. There's a number of serious challenges. Number one is cost. If you've ever set up DR, and I'm going to paint with a broad brush for just a moment, it generally means here's site 1 and here's site 2. I'm going to buy a great big SAN over here, and I'm going to buy a great big SAN over here. I'm going to buy some really expensive pipes in the middle. I'm going to do replication. That alone is going to stop a huge portion of the people that are considering DR. Next is complexity. Again, painting with a broad brush. But let's assume this is site 1, and this is running on 192.168.0.1. This now is gone. Now this workloads need to magically come over and start working over here on a 10.0.0.1 network, and everything just magically needs to work. Okay? That's tremendous complexity, and that's just talking about the networking. Inflexibility. When it comes to DR, generally it means this is a SAN and this is a SAN. And in fact, this is one SAN and this is the same exact SAN. Well, what if you have a bunch of branch offices? What if this is your data center and you've got a bunch of branch offices, and you'd actually like to be able to take those branch offices and actually replicate those back to your data center? Are you going to buy a SAN for every branch office? I've spoken to some of the largest oil companies in the world, and they've told me, they said, Jeff, this looks amazing. And I say, why? You're an oil company. You've got SANs coming out your ears. You've got data centers everywhere. And they say, it's not the data centers. It said, we have these branch offices. These branch offices are oil rigs in the middle of the ocean. On each one of these, we've got hundreds of these. We've got 10 to 20 servers. We would like to replicate that data back to our data center. But we can't afford to put a SAN on every one of these oil rigs. Now, when an oil company tells you they don't have enough money to do something, you have to stop and pause for just a moment. So there's truly a need out there. The initial replication can also be a huge challenge. It's one thing to say, hey, you know what, I'm going to replicate from Espoo to Helsinki. It's another thing to say I'm going to go from Espoo to London. It's an even larger thing to say I'm going to go from Espoo to Hyderabad. And finally, there are distance requirements. I did those backwards. I was actually thinking initial replication and distance requirements and got them backwards in my head. The initial replication can be a huge challenge. Say, for example, you've got 60 gigabytes you need to replicate, and you've got a very small pipe. It could actually take you days or even weeks to do that replication. When you couple that with the distance requirements, you've got some major challenges. Now, when you put all of these together, you can see why DR has been a huge challenge. This is why we've introduced Hyper-V Replica. Hyper-V Replica is built right into Server 2012. It is software. Number one, there's no cost. It's built right in. You don't have to buy something extra. Number two, it works with any storage. It works with direct attached storage. It works with your SANs. It works with your file servers. If I can read it and I can write it, then I can replicate to it. I've got folks on my team that have been replicating VMs between their homes over a cable modem. Okay, our goal was to bring replication to everyone, to make it available to everyone. This is not designed, I get asked all the time, Jeff, you're going to tell me to rip out my SANs? You're going to tell me to rip out my DR story that I have today? No. Keep that. I'm not telling you to do that at all. What I'm telling you can do is complement it, though. Or if you've never done DR in the first place, we've got a great solution for you here as well. This replicates VMs. It's asynchronous, which means it can go tremendous distances. We are replicating VMs between Redmond and Hyderabad. Literally halfway around the world. We've been doing it for a very, very long time. So that capability's in there. It's also application consistent. So when Replica takes a snapshot, it actually calls down into the guest, calls down into the virtual machine and says, oh, if you're VSS, please flush everything to disk, properly quiesce everything, and we're going to take that snapshot. So we're taking a replicated snapshot, and we're doing it application consistent. By the way, this is all integrated with clustering. It's all integrated with live migration and Hyper-V. So even as your VMs live migrate around your infrastructure, if you've set up replica, it's going to continue to replicate. So we've really thought about this. And honestly, we had our very first test. Literally weeks after Server 2012 shipped, Hurricane Sandy hit. And I have to admit, I saw this coming and I said, oh gosh, not this again. Hurricane Sandy right now, we're still tallying up the cost of this devastation. Right now, it's estimated between $60 and $70 billion. So it's not at Katrina level yet, but very, very bad. And the devastation has been terrible. And again, like Katrina, we watched it. We saw it coming up the coast. We tracked it very carefully, and we were pretty accurate when it was going to hit and where it was going to hit. Here's one example. Here's the New Jersey coast. This is May 21st, 2009. Take a look at the yellow arrow. The yellow arrow there is to give you context. That's your point of reference. You can see there's a highway there. You can see there's a whole bunch of nice houses. You can see the nice coastline. That's before Hurricane Sandy. Here's after Hurricane Sandy. Highway's gone. The coast is completely eroded and gone. Houses aren't there anymore. You can see the devastation here. Terrible, awful, and just humbling when you think about what can happen in nature. On the other hand, I'm happy and thrilled to say that within a few weeks of Server 2012 launch, we had people and customers waiting for the final bits to start deploying it. And literally, October 30th, I got this email in my inbox. And honestly, this is one of the reasons I come to work every day at Microsoft. I love what I do. It's about changing the world. It's about making it better. Good morning. The hurricane hit our area badly. Many downed trees, even on my wife's car. Flooding and total power cuts were everywhere. We're very grateful that everyone is well. I now want to thank the Microsoft 2012 server team for giving businesses the new replica feature. Two of our clients, both who cannot be without their IT infrastructure, were flooded entirely and might take 2 weeks to get back into their businesses. At 7 p.m. last night, we failed over their entire domains to the replica site, and then they've been able to continue their daily business with zero interruption. Windows Server 2012 saved their business. So I'm thrilled, I'm humbled, and I'm just fantastic that we're providing this type of solution. If you've thought about DR, if you've considered DR, if you've been put off by the cost, the complexity, the inflexibility, please take a look at Hyper-V Replica. It's simply built into Server 2012. The industry response to what we've been delivering in both Windows Server and System Center has been nothing short of amazing. And this is even looking at some of our harshest critics who generally give Microsoft, pretty hard time in the press. Windows Server 2012, must-have OS for cloud. System Center Configuration Manager 2012 is absolutely amazing. Windows Server 2012 from Microsoft, and I mean literally nothing has ever been this ambitious. Windows Server 2012, System Center 2012, CRN Products of the Year. Finally, analysts have been saying this. For users contemplating a major new cloud or virtualization project or initiative, Server 2012 should be the platform of choice, and any preconceived notion about Microsoft versus VMware for the virtualization layer need to be re-examined. So we're really, really quite humbled and happy to see that we're getting such a great reviews across the board. The industry's ready. Hardware's out there. If you want to start deploying Server 2012, we've been working with hardware partners, software partners. If you go to our Windows Server catalog online, you'll literally see hundreds of devices, servers, etc., that are all ready to go, already certified for Server 2012, applications that are there and ready to go as well. Systems integrators. We've been working with them, and if you are a system integrator and you haven't been trained on Server 2012 and System Center 2012, we want to make sure you do. Because honestly, one of the biggest questions I'm getting asked every day is, Jeff, this looks great. Is there someone you can point me to that will start setting one of these up for me? I want a Microsoft private cloud infrastructure in my environment. Is there someone, is there a consultant, is there someone that can come and give me that type of advice or service? Service providers. Service providers, if you looked at Replica, if you're a service provider in this room and you looked at Replica, I hope you thought one thing in the back of your mind. Wow, I could be a service provider. I could be that disaster recovery target. Because what's nice about Replica is literally you set up a server. You don't need special hardware. You don't need a special SAN. You don't need a special infrastructure. It's literally set up a server and enable Replica. There's a reason why we made it easy on the customer side as well as on the hoster side, because we want everybody to be able to consume this. Make it very, very easy. So, System Center and Windows Server 2012 available now. I also want to point out there's so much excitement about System Center that, in fact, there's a Finnish company, Onrigo, that is delivering management as a service. So here in Finland, the Onrigo Online System Center. So, for example, you may be thinking, you know, I have a small infrastructure, or I would like to get better control of my infrastructure. I haven't set up System Center. Gosh, wouldn't it be great if I could just take advantage of someone who's set this up already and provides me a System Center solution that I can use already as a management as a service play. It's available right now. If you're a municipality, it's a fantastic solution. If you're a company of any size wanting to get better information about your applications and your workloads, here's a great way to do it using a local company. Finally, I want to mention again, I'm doing a deep dive later. I talked about performance, scale, and networking. I'm going to go into how we did some of these things, why we did some of these things, and more of the deeper dives later. So with that, I just want to say thank you very much. It's an absolute pleasure to be here at Tech Days in Finland, and I will see you a little bit later. Thank you very much.